I'm presenting joint work with Daniel Gaskell here. Enciphered, after all, word-level text metrics are compatible with some types of encipherment. The issue we're addressing today is the conundrum of the partially language-like and partially non-language-like statistical characteristics of the Voynich manuscript. Voynich text has characteristics that don't resemble natural language at the word or character level. For instance, in the predictability in character sequences, high degrees of some character predictability, line position skewing, and many others that have been noticed by Reddy and Knight, Courier, going back to the early work on the manuscript from a linguistic and computational point of view. But at the paragraph and page level, the Voynich manuscript does have properties in common with natural language that Reddy and Knight, Montemurro, Sterneck et al. And others have commented on. For example, topics that co-vary between the scribe and illustration, or page clustering, where adjacent pages appear to be more similar to each other than to random pages in the manuscript. So this raises the question of whether the Voynich manuscript is gibberish, where these larger level scale similarities are epiphenomenal, or whether it's an underlying natural language where the encipherment method has made the text look rather non-language-like. So to get into this question, we need to think about what are some of the features of gibberish and what are some of the features of natural language, and where do these statistics arise from? Natural languages have phonology, morphology, syntax, and semantics. That is, they have sounds or signs, in the case of sign languages, that combine to form words. Those word pieces can combine to form larger words. These words occur in phrases that have a particular configuration and a particular syntax associated with them. And morphology and syntax have meaning, that is, semantics. These items convey a message. Gibberish, on the other hand, only has phonology. It only has the arrangement of characters in very local sequences. There's no underlying meaning and no syntactic regularity, except in as much as the producers of gibberish may inadvertently bring in syntactic associations from their own natural languages. Now, of course, natural languages differ substantially in their phonology, morphology, syntax, and semantics, as do gibberish creation methods. But overall, natural languages share a set of statistical properties that arise simply because of the way that language is organized. For instance, words occurring in particular syntactic configurations mean that some types of syntactic words are going to be much more frequent than other types of words. Word length differences hold as a general property of natural languages, and so on. There are going to be words that tend to cluster. So today, what we want to look at is this question about encipherment methods that might disrupt phonology but retain patterns in larger units by examining statistical characteristics of words in phrases and across larger scales of text versus local characteristics. So what we're going to ask these 4 questions, and hopefully at least partially answer them in this talk today. So what effects do textual manipulations, such as encipherment, have on statistical measures of text? What types of manipulations, if any, produce outcomes that are similar to Voynichese? Is there an interaction between the underlying language and the manipulation? And are there manipulations which produce a set of markers which are compatible with Voynich texts? And so these are the things we're going to be talking about. First of all, let me describe some of the methods and the background to the studies that we're reporting on. We start with a corpora, with a set of corpora, that we then produce different text manipulations on and then measure those statistics and compare them to the Voynich manuscript. So our corpus collections are a set of natural language corpora, Wikipedia corpora, plus some historical texts that have been used in other studies of the Voynich manuscript. The Wikipedia corpus was compiled by Rugg Lindemann and reported on in Lindemann and Bowern 2021. The other aspects of this corpus were used in Gaskell and Bowern 22, also reported at this conference. We compared these natural language samples to a modern gibberish sample created by students at Yale University as part of my Voynich class between 2017 and 2019, and the algorithm of automatic writing text compiled by Tim and Schinner. We also compared these to the Voynich manuscript in a range of transliterations, and compare Renee Zandbergen's plenary from this conference for why one might want to look at different transliterations. In order to do text manipulations, we looked at a number of different text preserving and text destroying manipulations. Text preserving manipulations are where the text is able to be recovered from the encipherment or the text manipulation. So in the case of a substitution cipher, where the plain text is substituted by a single character, then with a large enough corpus, we can do fairly straightforward frequency decoding in order to recover the underlying message. An example of a text destroying method would be something like replacing all the consonants with one item and all the vowels with another, as in our text destroying method here, where we are extremely unlikely to be able to recover the underlying message of the text, even if we're able to create a message which is grammatically coherent in the underlying message. We can look in more detail at some other types of text and cipher relations. So for instance, we could have a monotonic cipher where there's a one-to-one relationship between the plain text and the enciphered text, as in the top example here. A polyphonic cipher where many plain text characters are enciphered by a single enciphered, a single cipher character, such as C and D both being enciphered as X here. Or we can have homophonic ciphers where there's a one-to-many relationship. So here, for instance, the D character in the plain text is enciphered by multiple characters in the cipher W and P here. We can also, of course, have many-to-many ciphers where we combine these sorts of items as well. So in our work here, we took a number of text manipulations, some text preserving, some text destroying, some related to known medieval ciphers, others that take character properties of phonology and manipulate them in various ways. I've given some examples on the slide here, but see the paper for full details. We use 23 different items, and here's a subset here. So there are things like conflating all the voicing distinctions in the characters, removing voweled letters, adding consistent items to the end of every letter to mimic bigraphs, and so on and so forth, reducing the number of characters, expanding the number of characters, and so on and so forth. Note that this is not a full list. Note also that many of these are not actually plausible encipherment methods. They were created rather to test the statistical characteristics of different languages under different sorts of manipulations. All right, and future work would focus more on 15th century encipherment methods than we have here. This is, as I've said before, a proof of concept, work in progress, rather than a final project. You should see the paper for the full details of the statistical measures that we looked at. We looked at 42 different parameters involving characters, words, and sequences thereof. For instance, we looked at character biases, such as how often a character appears in a particular position in a line, a word character bias, how often it appears in a particular position in a word bias, how often words appear in particular positions, entropy measures, uniqueness, repeated characters and words, word length autocorrelation, which is the similarity of the length of words compared to adjacent words, and so on and so forth. And the paper gives more details on this. So with our 42 character metrics, we standardized them to account for different word lengths, and we compared our samples here to a number of Voynich transliterations. Here I'm just reporting on the comparisons to the EVA basic split by courier language, A and B. Note that some of these metrics are correlated, so even though we standardized our metrics so that they all contribute roughly equally to the similarity metrics, some of them are correlated with one another, and so that is likely to weight them disproportionately, although hopefully not too disproportionately. Okay, now for our results. Here is the first set of results. Here are two heat maps looking at similarity between the EVA basic, Korea A and B, compared to a number of natural languages in different encipherment methods. So the x-axis here is the type of cipher, the y is the manuscript in the case of ancient languages, or the Wikipedia corpus in the case of modern languages. The more yellow a cell is, the more similar it is to the Voynich manuscript, to A or B. So impressionistically, we can see that Korea B has more similarities than Korea A does. We can see that the underlying language matters. So, for example, this line here shows the devoweled text manipulation, and we can see that Uzbek and Turkish are more similar to Korea B under this metric than this overall metric than, say, Hawaiian here or Tswana, which I think is here. But we can also see that the underlying text matters. We have a number of different Latin esoteric texts, the Steganographia, the De Magia, and the Secreta Secretorum, and a number of others, but we'll use these three for examples. For the devoweling condition, the Steganographia is closer to Voynich B than De Magia or the Secreta, but the Secreta is closer on affix transforming, where we replace all of the affixes with a single set of sequences. So not only does the encipherment method matter, but the language matters as well. There are a number of pattern matches that seem to recur as being relatively close to the to Korea B, at least. For instance, removing, or at least that make the overall pattern more similar to the Voynich manuscript, particularly to Korea B. These include removing phonemic contrasts, so replacing T and D or K and G with a single character, replacing prefixes with predictable sequences, removing vowels, or sorting letters into alphabetical order. Some of which, but not all, we might think of as being text preserving, at least to some extent. Here is another example of overall similarities. Here we have the closest matches to the Voynich EVA basic along the, so these were normalized with the EVA basic at 0, and then we looked at the distance of the overall set of statistical metrics compared to Voynich EVA basic. And so we can see, perhaps somewhat relievingly, that the closest matches to Voynich EVA basic are other Voynich other Voynich transliterations, so Korea A and B independently, or the EVA full set of items. We also see a number of other samples somewhat close. We can see that the tail is long, and there's not a whole lot of difference between them here. And we have both gibberish and natural language, historical and modern samples closest here. But note also that they're not particularly close. So on a scale of 1 to 10 here, where we see none of these samples are particularly close to Voynich EVA basic. Even the other Voynich transliterations are not particularly similar. Okay, so we should treat this as a very cautious result here. Finally, we looked at some individual measures of items. So in this case, we take the the four most similar overall manuscripts to the three most similar manuscripts to EVA basic overall, and we z-score each individual statistical measure to see how much it differs from Voynich. So the 0 here on the x-axis is this line is the Voynich EVA basic line, and then the y-axis here are the statistical measures, such as flipped pairs, or the entropy measure, or the character bias, mean and skew, and so on. And so we compare this to 3 different items: the Uzbek with no vowels, the De Magia, and the Secreta, and we also compare it to a random sample, the Tim and Schinner algorithmic writing here. And you can see that none of these none of these items co-vary particularly with the Voynich manuscript, at least the EBA basic sample. They all are relatively close to Voynich on some statistical measures, but very different on others. So, for instance, the random algorithmic writing gibberish items from Tim and Schinner are very different on the word uniqueness measures out here. The Uzbek no vowels are quite similar in these sets of measures, but much more different on the character bias measures and so on. So we don't find a single set of encipherment methods that are consistently similar to the Voynich manuscript for any of these particular measures overall. So let me now round up and conclude and give you some future directions. So first of all, our future directions here involve other types of tests. We need to better understand the relationship between the language and encipherment method, because as we saw here, the measures differ pretty substantially. We need more historically accurate measures. Luckily, there have been publications in the last couple of months which now provide a way forward for that. We should further consider which measures are most important. We should probably combine encipherment methods in some ways, because these methods co-interact with one another. So, for example, some increase entropy, others decrease entropy, but if we have reason to suspect that both might be going on in the same encipherment method, we would want to test for that. And we should also consider measures of decomposability or decipherment, of readability and decipherability for humans, not simply breakable in algorithmic terms. So in conclusion, to go back to our original questions that we started with, what effects do textual manipulations have on statistical measures of text? The statistical manipulations that we looked at produce a range of effects on the measures studied here. Some of them bring natural language samples to within Voynich ranges, while others do not. Some types of manipulation do produce outcomes that are similar to Voynichese, but not across the board. So they may produce similar to Voynichese text on some metrics, but not on others. We did find an interaction between language and manipulation. That is, if we're going to try to brute force solve the Voynich manuscript by making claims by trying different sorts of encipherment method, we're going to have to pay a lot of attention to the underlying language. For these sorts of text manipulations, the underlying language mattered quite a lot. We need to consider whether there are manipulations that produce a set of markers which are compatible with Voynich text, and so far we did not find that. And so with that, let me pause, and we're happy to take questions. Thank you for your time.